Am I audible?
Yes, please.
Yes. Okay.
Yes, sir.
So, so far, how is the course? It'd be nice that I will get a feedback. Yeah, I saw that somebody put a comment that okay, that solution 6 was uploaded wrongly. I informed them and they changed it. Yeah. So, as far some doubts or something, so that we can solve the solution. Assignment 6. Most of them are like trivial. Okay, I saw that comment also. Yeah, okay, I'll contact them and I'll change that video. Okay, that week 8 video they are saying that is private, they are saying. Okay, let's see. Which video is private? Somebody informed in the group that week 8 videos are private or something.
The first one, sir.
Week 8 first video. Just see that I'm going to share my screen. Whether you people can see that or not, we just see.
Okay, sir. That video is not visible now.
Okay, for you people that video is not visible. Okay.
Yeah, there was something on Teams.
What it is showing? Only IIT people can see or something it is showing. Because I tried to access that video. I can access. This is week 8 video, na? Transformation of a Gaussian beam. That is the one people are studying.
Yes, sir.
Okay, that video is accessible for me. Maybe they changed it in such a way that okay, this IIT may can access. Okay, can check that. Maybe people can see my screen now.
Yes, sir.
This video you people are saying.
the R of the wavefront, you have a spot size
That is visible, sir.
omega,
The first one is not visible.
and immediate
Okay, transformation of a Gaussian beam. Just,
Yes, sir. That is not. That is private, sir.
okay,
Video is
let's see. This one.
This is not visible, sir.
Okay, okay. I'll contact them and I'll make that to public access. Okay. So so how today should we start? Whether it will start with your doubts and whether we want you people want to do questions or this exercises or something. What will we prefer? Like that way I can go. Which which way you will prefer? Like that way. Last week I think Raju sir was there, Kiran Jog Kaur was there. And last time we went in such a way that you people were doing. I was just uh, just seeing only means and just instructing. So that's way this time you want, or whether I should directly go for assignment solution.
So you can start with the Oslo questions and uh, assignment question, then random lab practice. At
Okay,
the end, you can go for assignments if it's possible.
okay. Yeah. Anyway, just we can just okay. So you people want this Oslo practice questions first.
Yes, sir.
Yes, sir.
Okay,
And lab assignments also, sir.
okay, okay. Let us see. So you people want to do by sharing the screen, or I have to do that also can be done. Last week we went like that way. You people were doing, and I can instruct how it should go, or I have to go. Anyway, just we can just move through till Oslo. We can just go through that assignment questions. Till sixth question, I think it is a trivial only. You people can just say the answer, and just we can start our Oslo thing. Okay.
Okay, sir.
Assignment. Assignments. Yeah. Let's see. What is the chromatic aberration? You people can tell, and we can move fast. What is chromatic aberration?
Um, Sir, when the light is getting splitted up into different colors because of different wavelength.
Yeah.
So,
The thing is that how we are imaging, we are thinking that all the light rays coming from one point, and after passing through this optical element, it is focusing at the same point such that we are getting the image point. This is our fundamentals of imaging now. But the elements in our optical system has some glass kind of thing, or some refractive thing. But the thing is that the refractive index, which helps them to bend the light, has a it is a function of the wavelength of the light. So even though a light ray which is coming from one point is actually composed of different wavelength of the light. For example, if a white light is coming from one point, means that light itself is composed of we can say that seven color or something. But yeah, primarily it is composed of three color: red, blue, and green. What will happen? This red, blue, and green has different refractive index through when it is passed through a refractive element. What will happen? Because of the difference in diffractive index, the bending of the light will happen differently, so that even though we are ideally, we will think that this all color will focus at one point and give the same white light at that point, but because of this variation in the refractive index, this will focus at different point, and instead of one white spot, we are getting some colored spot from red to violet. So because of this change in focus due to the variation in refractive index of the optical material, we are getting a colored band instead of a one spot, and this problem is called chromatic aberration and causes a variation of refractive index with the wavelength. Okay, next. If white light is incident on a thin convex lens, which of the following statement is correct? Blue light get refracted more than red light. Red light will focus closer to the lens than blue light. Both blue and red light will get focused at the same point. Image will appears to be colored. Already answer is there. Yeah. What is happening? Which will bend more? Higher wavelength means bending will be higher or lower?
Lower, sir.
Higher wavelength means the bending will be lower. So you people can see my screen. I'm not shared my screen now. You are seeing my screen now. Hello. You people are seeing my screen now.
Yes, sir.
So just think that okay. In normal case, what happens? A light ray is coming here. After refraction, it is bending and it is getting focused at some point. But actually, this light ray is composed of a different color: red color, green color, blue color, like that way. What happens after everything is bending similar way? Which will bend more? Which has the bending more? When it is passes through a refractive medium, blue will bend more. Green will have a less bending. Red will have much more less bending. So instead of focusing at one point, this rays will this ray will go and hit at a different point. These are all are actually represented by single point, but you will get a instead of getting a single point, you will have a variation because this blue point and this red point has to be focused at the same point, but it's instead of it is having a distance. There is a longitudinal difference, and that difference is called actually chromatic aberration. So, which will bend faster means more blue will bend more, red will bend less. Okay.
Yes, sir.
Third, for most of the optical material, the relation between refractive index and wavelength lambda. So it is related. Same thing using that same thing we can tell that also. What is actually
Inverse relation.
yeah? What is actually causing the bending? What is the causing of the bending is actually refractive index. Refractive index is the one which causes the bending. So more bending means a higher refractive index. So which will have higher refractive index? Lambda means a lambda having less lambda will have higher refractive index, and the light with a more lambda will have a least refractive index. So the proportionality will be inverse. So it will be like 1 by lambda. Actually, this is a refractive index is a complex function of a wavelength. This 1 by lambda is actually a some more or nearby approximation we can say. Actually, there will be some relationship which is saying that it's a function of 1 by lambda plus 1 by lambda square plus something extra like that it will go. But the effect of 1 by lambda square will be much less compared with 1 by lambda. So we can just take this as our for majority things we can take this value. Okay, got. Next, in a achromatic doublet which has higher dispersion. What is an achromatic doublet? What is achromatic doublet?
Combination of concave and convex legs, that is negative and positive one.
Yeah. Why we are combining that together?
They are combining together because of Abbe number, na?
Yeah. Yeah. With respective of the Rabbe number, we will they combine together. But why we are combined together?
Because they cancel each other.
Yeah. Then
Like,
if they are cancelling each other, we don't want any lens. Na?
yes.
If I am combining two lens together and if they are cancelling each other, then there is no point of combining. Na? Instead of lens, I can use a glass.
Uh,
So I think it's to like remove the aberrations
Yeah.
to an extent.
We will not combine two lenses having equal power. Okay, we will combine two lenses which is having a different power. Like that way, we will not. That combined power is the our original requirement. You understand? Like that way, if one lens having a 2 diopter power,
okay.
just think that I am having a lens. I am having a lens, convex lens, having a power of plus 2 diopter, and I am having a similar material, same lens, have a minus 2 diopter. The same material. So it's a BK7. This is also BK7. What happened if I combined these two lenses together? Just assume that they are thin lenses. In this lens, what happens if some parallel rays are passing here? What will happen after? Think it will focus. Correct? Huh? In this negative lens, what will happen? It will diverge. Correct? Any doubt for this too? Hopefully not. Now I am combining these two lenses together. What will happen if I am putting a parallel rays here? What will happen? Well, anybody can answer. Anybody can answer. What will happen? Tell. Just guess. Just give me a guess. Give me some guess. If people don't want to guess, I'm not seeing.
It'll be parallel. It'll be parallel and no change.
Yeah, if they are having same material with the same plus and minus focal length, what will happen? This concave lens will try to converge, and this convex lens will try to diverge, such that it will come out. So, such that it will come out again parallel only. So there is no difference between this combination of lens and there is a plain glass slab. If you are using same material lens with the same equal and opposite power, okay, but in the case
Sir,
of,
in last lab we used to get parallel rays with a with a shift. In this also we will get some shift, or
yeah,
it will be just as straight as that.
yeah, now you see, when the glass slab is shifting the rays, if they are coming at a particular angle, it will go like this way and you will get a shift.
Yes, sir.
Yeah, similar way. But if it is a, if if you are putting light rays to parallel to a glass slab, no, sorry, parallel, perpendicular to a glass slab, what will happen? Is there any shift will be there? It will go like this way. In that case, there will not be any shift. Only some phase change will happen in between. That will be the shift. But the rays will go as parallel. So, is there any good thing will happen if you combine the two lens with the equal power? So there will not be any good effect if you are combining two lenses with equal power. But we did the mathematic calculation such that V1 F1 plus V2 F2 equal to 0. If this criteria satisfied for a particular wavelength, what will happen? And that particular wavelength will be that in between, like yellow of red and green. And so we will select lenses in such a way that this V1 F1 plus V2 F2 will not be equal and opposite. You got it? Understood? You had one you had one criteria for minimum chromatic aberration. This V1
Yes,
F1
sir.
plus V2 F2 is equal to 0. Just think that if V1
Yes,
and
sir.
V2 are same,
Yes, sir.
V1 and V2 is actually defined by what? The material of the lens.
Yes, sir.
Yeah, you just think that if V1 and V2 are same, what will happen? F1 and F2 will be same. Got
Yes,
it?
sir.
This is your criteria for minimum chromatic aberration. E1 F1 plus V2 F2 equal to 0. And it just think that if V1 is equal to V2 equal to V, so you will get a Vf1 plus Vf2 will be 0, or Vf1 is equal to minus Vf2. V and V will cancel. F1 is equal to minus F2. Then this is the condition. You will have a two lens material with the same power, because V1 and V2 same means they are same lens. It will give a least chromatic appearance. That's true. That is a truth. But that doesn't have any effective power. It will be like you are using two lenses. You are buying with a lot of money. You are buying a concave lens. You are buying a convex lens. You are combining together. But after that, there is no lens is there effectivity. It is just giving a like a glass slab. Actually, you don't have to. You don't need to buy a lot of. You don't have to expend give a lot of money for buying that lens. Instead of that one, you could have a use a glass slab. But actually, you want a lens having a particular power. In that sense, what we will use, we cannot use two lenses with the same material. We will use a lens having particular power and with a different material as concave lens, and there will be another as a convex lens, and there will be another material lens having a with a different material as convex lens, and in such a way that this combined lens system has a particular power, and that particular power is our power of interest. What will happen in that case? In that case, even though this red and blue, but in the case of a normal lens, if you put a red and blue, sorry, blue separately, the blue will focus first, red will go far. And in the case of a concave lens, in the case of a concave lens, oh sorry, red and blue is coming parallelly, what it will do? Red will go, red will have minimum deviation, but blue will have much more deviation. So by combining here, what will happen? We will make sure that here, in the case of this convex lens, red will have, blue will have maximum here, and maximum here also. Red will have minimum here and minimum here also, such that this red and blue will focus at the same point. Okay, such that your chromatic aberration will be minimum. In that sense, this lens material should be different, this lens material should be different, this lens material should have a particular power, this material will have another power, such that this combination of this lens will have a particular focal length. This focal length is a combined focal length of the, it is not a it's not a, it's not a single focal length of something. Okay, got it? So now the question. In an achromatic doublet which has a higher dispersion. So usually in an achromatic doublet we will use a 1 BK7. So it's like a BK7 means a borosilicate crown glass. That is a BK. So usually we will use a crown glass as first material, then flint glass as a second material. Out of the which one? Which will have a higher dispersion. Higher dispersion means a Abbe number will be higher or lower. Higher dispersion means a,
Lower, sir.
yeah, higher dispersion means a Abbe number will be lower. And which kind of glass will have lower Abbe number? Crown glass or flint glass? Okay, already you are seeing that answer also, but yeah. Which will have a higher Abbe number? Higher Abbe number means a lower dispersion, and crown glass will have lower dispersion. Sorry, higher dispersion and lower Abbe number. Okay. Now, a combination of diffractive and refractive lenses can correct chromatic aberration. Choose the statement which gives the right reason. Both lenses have, now it is just see that combination of diffractive and refractive lens. What is a diffractive lens? diffractive lens, you people didn't go through that. I think that lecture is coming much later only. There is some, whatever we are dealing with is like a refractive optics only. So all the light bending is caused by refraction. So but there are actually the phenomenon, and all the refractive optics we are explaining in terms of geometric optics. But there are phenomenon in which we can bend light using diffraction. You already know that one, na? Bending of light at the edge of some opaque body is called a diffraction. You have seen already. You people may be knowing. In that case, we can use special elements to focus, or as a imaging tool also we can use diffractive optical elements. One of the important thing for the diffractive optical element is that we can put a Bay number of the diffractive optics element is negative. Okay, here you can see that in the case of a achromatic doublet, we are particularly using this concave lens in order to get the this V2 F2 portion as negative, because we know that V2 is a Bay number. It is the ratio of that refractive index and other things. So that is never going to be negative. So only the option we are having to get a negative and make this sum 0 is we have to put a negative focal length. So negative focal length will be given by a concave length only. That is the reason it will be a combination of convex as well as concave. But in the case of a diffractive optical element, you can put a negative Abbe number element such that it will give a chromatic aberration 0. Okay. So the answer is combination diffractive optics is there. You can directly use it. Refractive lens has a positive Abbe number and the diffractive optic has a negative Abbe number. Got it? Now see, if you needed to focus a multi-wavelength beam, multi-wavelength means a beam containing a lot of wavelength, and you want to minimize the chromatic aberration. What is the point, or how you can do that one? You have an option that you can use mirror, lens or mirror, diffractive lens. Which is the easiest way? Which will be the easiest way? Which will be easiest way? Tell. You already have the answer there, so at least you can just repeat the answer. Which is the easiest way? Because you want to minimize the chromatic aberration. Chromatic aberration is happening because of a changing refractive index. How the refractive index is coming into the play? The because of refraction is happening. Refraction will happen only if there is a transmittance is there. But we can use mirror. Mirror does not have anything to transmit through that one. There is no refractive index incorporated in terms of mirror. So if you are using a mirror for imaging, you don't need to worry about chromatic aberration. You people know about the telescopes, na? You know telescopes?
Yes, sir.
Yeah. There are different kind of telescopes. Refractive telescope and a reflective telescope.
Reflecting. Yes, sir.
Okay. So what is the advantages of reflecting telescope over refractive telescope?
So less aberrations.
Yeah. Chromatic aberration will be very less because the primary lens will not be there in the case of a reflecting telescope. Instead of, there will be a big mirror. So there will not be any chromatic aberration because of your primary optics. But there are like eyepieces and other thing that will be like lens only that you cannot change. There will be, but chromatic aberration will be minimum. Otherwise, you can see that, or you can clearly see that you people may, I don't know, any people saw something through binocular, like it may not be like expensive binocular, like a cheap binocular which we are getting like in our festivals and other thing. You can see the toy binoculars. Whether anybody watched through that system, some,
Yes, sir.
yeah,
Lot of chromatic aberration.
yeah, you can
Lovely
see,
colors and all.
yeah, you can see that this if you are looking at a some distant object, you can see that all things are like colored. It is like a multiple colored object you are seeing. Why you are seeing that one? Because they are cheap, they are just using some combination of the lenses, but they have a higher chromatic aberration. And you can similar thing you can see in terms of expensive. Anybody have doubt? Okay. So similar thing you can see that there will be some expensive lenses, binoculars. Yeah. Anyway, hopefully I think that you nobody has a chance to open a binocular and see how the lenses are arranged. There will be two kind of lenses arranged in the binocular. You can see that two big lenses in the front portion, which is called a primary lens, and there will be a lens which is at the back side where you are, where through which you are looking. That is called eyepiece. You just if you open the binocular eyepiece, you can see that if it is a good binocular, that even that eyepiece, which we are thinking that's a single lens, that will be a combination of 3 or 4 lenses to minimize the aberration. Okay, this is the way it is working. But yeah, the simplest way to avoid chromatic aberration is that avoid the elements which will cause a chromatic aberration. So here you have the option like use mirror. So directly you can use the mirror. The- Next, a lens system consists of a combination of convex and concave lens. The concave lens is made of flint glass in order to reduce the chromatic aberration. The lens system, which of the following glasses would you choose as convex lens? Now we see. Just tell, which I already told. If you are using a achromatic doublet, this consists of two lenses. One will have a convex lens having a higher Abbe number, and one will have a concave lens which have a lower Abbe number. And the lower Abbe number glass, usually it will be a flint glass, and the lens with a higher Abbe number will be, usually it will be a borosilicate glass. This is the most common thing. So what is the answer? So the convex lens will be a lens which is having a higher Abbe number. So here that most prominent answer will be like 64.17. Okay. So our theoretical questions are over. And now we can start. Now you people can tell that whether you people want to do by yourself and showing in the thing, or I have to do. It's your choice. What do you people prefer? You have doubts in Oslo and other thing, it seems. Correct?
Yes, sir.
Yeah, you can tell what, how we want to start or how we want to do.
Sir, sir, you can show. I am driving actually, so I
Okay.
can't. If anybody else can, then it's okay.
Which portion actually you people want? Tell. Which portion of the Oslo?
Sir, assignment questions and lab questions.
Yeah, which portion? Last time we did some questions, na?
Sir, in the end, there were 3 questions. No?
Where? Assignment. Or this three question. Okay. So we can directly go through these 3 questions.
Sir, at the last, they
This,
were, yes, 8 to 10.
this 8. Yeah, that's why I was asking that. Yeah, means whether you want to start with here. So till here you can do.
Yes.
Okay. Here, anybody has a doubt? Now I have a doubt. Let us see. Because that all questions are the other. You people go through the solutions of that assignment 6. Because I think that one instruction is missing there. This after the 8, this portion is the this portion is not the question, na?
No, sir.
Yeah. So till 8 is valid. Yeah, 9, 10, how it is valid, I will check. I will discuss with these people and tell. Okay. Anyway, we can do with based on this thing. Now you see, what is the question? Model a lens whose first radius of curvature is 100 millimeter and the second radius of curvature is minus 100 millimeter. Let the second surface to be aperture stop. Let the entrance beam radius is 5 millimeter and the field angle to be 20 degree. Let the thickness of the lens be 10 millimeter initially. Use the lens thickness as a variable. Generate an error function for EFL. It's a effective focal length. Using OCM 21 and optimize the EFL to be 100 millimeter. Anybody want to do? Anybody want to do this thing by sharing the screen? Anybody want to do? You can do. If nobody wanted, I can do. Okay. So what you have to do? You have to start a lens. So I'm going to start our Oslo. Tell me what are the things I have to do. I will hear your voices and go through like that way.
Beam radius and field angle can be entered.
Yeah, tell me. I'm not here. I'm not seeing that one, so you can tell. I will enter. Beam radius how much?
5,
5. Field angle
20.
you can tell me what to do. Then I have to add my surface. Now I can see that how many surfaces are here. One object is there, one image surface is there, then only single one surface is there. At least I want one more surface.
3 surfaces.
Yeah. So I will add one more surface. Okay. Okay. Now, what are the things to be defined? Well,
First surface is
radius. This one. What is the radius they defined? They defined it as
100,
100. Next, I am going here. Thickness
10,
10. Aperture radius. I am not.
minus 100,
Aperture radius is minus 100. Aperture radius is actually that is actually, since you can see that there is a AS. Now, what is meaning by AS? The A is actually defined as a aperture stop. So it is considering the first surface as aperture stop, and S is defined as a, what's the meaning of S? S is solve. So it is got, we already defined the beam radius as 5 millimeter. So based on the 5 millimeter, it is just calculating the size of the aperture stop. That's why it is written as a, it is automatically taken as 5.
oh,
Okay.
okay,
Yeah. So this is aperture radius. This is, we can increase also. I will show you. Now this is medium. The first surface medium. You people, whether I have to draw. Now what we are doing? If you people have Oslo doubt, na, you people may be knowing that. I think mostly our all the Oslo thing will be going to be over by next 2 weeks. I think. So if you have some doubts, it is better to be clear. After that, our module itself will change to another level. Okay. So you see what we are defining. Now we want, I just define an optical axis, and now my object is somewhere. I don't know, but I am saying that there is a field. There is a radius. Beam radius is there. Some beam radius will be there. I don't know, and and that beam radius I already defined. Some beam is coming. Light beams are coming at a particular radius like this way, and there is a beam angle also. So I can say that okay, some, this is like a, some at a particular angle beam is coming with a radius of 5 mm. I'm saying that it is coming at an angle of 20 degree based on this line. This is the thing which I defined at that first time. Okay. Now that already I defined. So I have a beam having a radius of 5 millimeter and an angle. So some beam is coming. Now I am going to define my first surface. There is a first surface is here, but I know that that surface has a radius of curvature of 100. So I am giving a, the first surface has a, I am giving a radius of curvature 100. This is the thing which we did. When I am putting 100, which is the one, this is first surface I defined. Till now I don't know what is this material here. Okay, but I know that there's a first surface having a 100 radius of curvature. This is the thing which I defined. Now I am saying that it has a thickness of 10 mm. So from that first surface, it is took a some 10 mm. Okay. Still, I didn't define the material here. Now I am going, see 5. Let it, don't think about this 5 here. Now it's air only. So there is no point that there is a surface with the air surface. Okay. There's a air surface having 100 mm radius of curvature doesn't mean that there is a surface there. So actually there will not be any surface in that case. So I want to change it to a particular material. In that time only, I will fill this portion with a material. What is our material?
okay, 7.
BK7. So I am going to fill the material with the BK7. Okay. Now I can draw and see how it will look like. See, so that beam angle, this is the beam radius 5 mm. This is the total beam diameter. Yeah, 5 mm radius will be there, and at a particular angle, means a 20 degree angle beam is coming. Now I have to stop that one. Now only I told that only I defined one surface and a material. So if it didn't close to that material, what will happen? Oslo will think that this whole surface is like our BK7 only. So somehow I have to close this material. So when we are closing the material, one more surface will come. Correct? So in that surface, so till this portion it is okay. This first surface is okay. So we already defined that one. Now another surface is coming. So I am saying that I am going to close the first surface with the material, and that this surface how we are closing with a surface
Minus
having a radius of curvature of -100. Okay. So what is Oslo understood? Oslo understood that okay, there is a surface which is having a, now we see that this is a radius of curvature is positive 100, like that way. Now this is having a radius of curvature -100. So we close the surface, and I am saying that what is the material after that is actually
Yeah.
air. So you see, yeah, the material after that is actually air. Now I want to see where it will be focusing or something. So after the surface also, either I can put a solve here, but I will not put a solve here because I want to do something afterwards. So I am putting here solve axial ray height 0. Now I automatically calculate at what distance axial ray height is going to be 0. What's the distance? After the second surface, or the second surface means yeah, this surface, after this surface 95 millimeter apart, that axial ray height is going to be 0. That the Oslo calculated by itself, and so just like this way it is calculating that if some axial ray is coming like this way, after this 95 millimeter, it will, the height will become 0, means it will focus. That is the thing Oslo is telling to us. But now we are not seeing that. We are only seeing this much portion. How we can see that one? So in order to see that one, I want to give a command that I should draw that particular surface. So we will go here, take surface control, go to general, and I have to put here draw. Okay. So it is now it is drawing the surface 3, but I want to see the image also. Means where the, go to surface draw. See. So this is the point where the axial ray height is going to be 0. Okay. And the focal length is how much? 98.43 millimeter. Okay. Got any doubt? And they already told that we have to define that second surface as aperture stop. But now we see AST. This is a AST means this is the aperture stop. First surface is the aperture stop. So we have to go and put it here. Put it as aperture stop. So now we see the second surface as aperture stop. So you made a lens. Okay.
Sir, can you repeat again the solve?
Solve. What is mean by solve? You are solving a particular parameter to get a particular value. Okay.
Okay. Okay.
Yeah. Now you see here. Now you defined this AS, aperture stop.
Okay.
You already defined your second surface as your aperture stop.
Yeah.
Okay. So we are defining that our beam radius is 5.
Yeah.
So what is required? Whatever a 5 beam radius is coming from this side should pass
Okay.
through the system. That is the thing which we are defining and telling Oslo.
Okay.
Okay.
Hmm.
In order to take the entire beam inside, please
Okay.
say 5 beam radius, 5 a radius of having 5 millimeter and a
Okay.
field angle of 20 mm. In order to accompany that one through the second surface, the second surface should have a width such or the aperture size such that it can containing that full beam.
Okay.
So Oslo is adjusting by itself that size, the radius of that aperture should be 7.48. You see here the S is already there.
Yes.
Since this S is there, it automatically taking the minimum value of that aperture should be 7.48, that your entire beam will pass through that one.
Okay.
I can increase this one. I can increase this one to some 10.
Uh,
Now you can see that that solve is gone. Still nothing going to happen because whatever the value I entered is higher than the required.
okay.
So it will pass through, the light can pass through still that one. It is not going to affect our system.
Okay.
But just think that I purposefully decreased that one. You see,
Hmm.
this amount of light is actually decreased.
Hmm.
So if we just decrease to some 2, see that only less amount will come through this position. So this will actually reduce your light intensities coming outside will be much less. But
Oh,
there is no point that I am saying that 5 millimeter beam is passes through the system, because whenever reaching the second surface it will cut off deliberately other than this 2 millimeter size. So there is no point you are saying that a 5 millimeter radius beam is passing through,
now,
because
one more doubt, sir.
yeah,
That is aperture stop. They are said it is in the second surface.
yeah,
Therefore, it should be in the next one now, sir.
ah, that is actually I am defining now.
Yeah.
Now what I did deliberately, now I deliberately cut this 2, even though they thought this as aperture stop is A.
Yeah.
We defined that one as A
Yeah.
previously.
Uh,
Now we deliberately cut down the whole light from the first surface itself.
okay.
So now even though you are saying that this is aperture stop,
Yeah.
there is no point as because this will not take that much light. This will only take very less light than it could contain.
Uh,
Now you see that now I am going to increase this one 3. Yeah. Okay. Yeah, this 7.48 is like that way. Yeah, this 4.282 is the one which is they picked up. So even though if I decrease this value, it is not going to cause that one. So I am going to decrease this one.
Sir, the beam thickness,
Beam thickness. Get it?
the beam radius is 5 millimeter, no, sir.
Yeah.
Then the case it should have the same 5 millimeter.
No, no, no.
That is 5 millimeter radius.
Yeah, beam radius is 5 millimeter, and I am saying that that beam is
Yeah.
passing through this lens, and in order to contain that 5 millimeter, because these are powered elements, so it will focus. So after this one passes through, it will not have that much radius inside.
Okay, right.
So
But
it does
then the
not.
case the aperture radius should be less than 5, no, sir.
Yes, but you have a beam angle 20 degree.
Yeah,
So that should also containing in that one.
right.
Yeah, in order to both to containing, because you can see that this will be like something. So you will have a beam radius of this much, and you are going to pass this like this way, and there will be some powered element here.
Okay, fine.
So in order to containing that whole thing there, so it will be like something like a, it will be more than this one, na? Because
Oh,
it will be like this way. If you went here,
okay,
it will not be, if you want to contain everything, if you just put a 5 mm here,
okay,
this will not, you cannot hold all beam in this portion,
okay,
and it will not, just think that there is not a powered element. So if it is just going like this way,
right,
even in this case, you want a 5,
right,
but you just think that there is going to be a powered element here, so it is going to bend. There will be some bending here,
okay,
there will be some bending here.
okay,
So there will be some variation happening here, such that it should contain not only this beam, there will be some axial beam also there,
okay,
that also should containing in that one, such
okay,
that Oslo is solving and giving a minimum aperture radius. Actually we are defining to
okay,
containing that one, it should get that much radius, such that it will pass through that one. So if you are
okay,
changing deliberately in between, automatically that will become your aperture stop.
okay,
Yeah. So if you are decreasing this element
okay.
to some very 2 or 1, so even though you define this as aperture stop, you are actually deliberately, now you see automatically that portion became 2.
Now, can we do it, sir? As it is in the second surface itself, we are putting a aperture stop.
Yeah.
Then we can reduce the beam size, and
Yeah.
so that yeah,
So
so that
that
it can focus at
I'll check whether that. See, when I'm solving that, I'm putting it as solved. Actually, it is solving based on the 5 mm beam radius. So,
okay,
but if I put this like now it's solved actually.
okay,
That's why it is getting that value.
okay,
Now I'm putting like manually. I'm going to put some 2. It's showing that value, but I think it will not take that value. Even 2.
Actually,
I,
what I
I,
doubt is the first
I just do the.
aperture radius for a corresponding beam radius is 5. That is a 7.2 something. It is there,
That, that,
7.48.
that is minimum.
Whereas we can put a aperture stop in the second surface so that it can the beam height, it can be brought to 0.
Second, I didn't get it. What you are saying?
See, this as it is with the beam radius,
Yeah.
at the end of the first surface, because of the aberration refraction, it is now the aperture radius is 7.48. Now,
Not because
after
of
the second surface,
Yeah.
can you put a aperture stop?
Yeah, I can put
And
one.
that radius of this aperture radius, if it is something we are putting, so that the height of the image height, it is 0.
No. Aperture stop, actually it is not. This always different than this. Always different than that's all. This actual image height you are saying.
No, the image height, that's what they are saying. So the image height.
No. That is this solve. That is this solve. You are seeing that this thickness. This thickness solve. Whatever you are seeing, this aperture radius, na. That's always different.
Okay.
This is axial ray height. This is actually will not vary based on your aperture stop.
Okay.
Radius.
Okay.
This aperture stop. This is aperture radius.
Achha.
This aperture radius solve is actually adjusting the size of your aperture such that it will control the amount of light passes through that system.
Okay, fine.
Yeah. This solve. This is the thickness. Or this can be a thickness in the case of a lens. If we are saying about this is the thickness. You are seeing my pointer, na?
Yeah.
Yeah. Now you see this is the third surface. This is the third surface.
Okay.
So third surface thickness means sorry. Third surface thickness is this one.
Yeah.
This is third surface thickness.
Oh, third surface is yeah.
This is third surface thickness. This is the third surface thickness.
Okay.
This is the third surface thickness.
Okay.
So here what we are giving the solve, here we are deliberately saying also that you can see that this third surface.
Okay.
I am saying also solve.
Okay.
Based on what you have to solve. Oslo is asking. I want the axial ray height.
Right.
I am saying that axial ray height should be 0.
Okay.
So I have to define a thickness. Thickness means this is the distance.
Okay.
Such that axial ray height is 0. So we already know that axial ray means it is the ray which is coming from the axis at a point, and after refraction again, if it is coming to the same point on axis, that means
right.
this is the focus point.
Right.
So
that's
that's why it is taking that distance.
Okay.
So instead of actually I can give a value like that, axial ray height should be some 1 mm or 0.5 mm. So you can see that now you can see that this is around 95 mm. So if I just say that enter solve value, whether it will be higher than 95 or lower than 95, you can just guess. You just guess it, whether it will, if I put a enter solve value 0.5, I am going to put a enter solve value as 0.5.
Okay.
Whether it will be higher than 95 or lower than 95.
Okay, fine.
You just,
I understood, sir.
Yeah.
Right. I understood how the
yeah.
by giving a solve value, we can adjust the
So I am going to give it 0.5 here.
Okay, fine.
So just to tell how it will be look like the image.
Yeah, slightly it is earlier.
Yeah, and it will not go to that particular point.
Right.
So see.
Yeah, right.
So there are like a different solves are there. So your aperture radius solve is actually controlling the amount of light passes through the aperture. And this thickness solve is actually controlling the how you want to get that axial ray. This is axial ray you are defining. Either we can define chief ray or like that, different rays you can define and different. And we know that the point at the focal point, the axial ray height will be 0. So
Yes.
we are using
The
that.
axial ray height.
Yeah, that is as our easier method.
Okay, fine.
Okay.
Okay. Solve axial ray height 0.
Now
Okay.
you got like a 98.43 as your effective focal length.
Right.
Now the question is that what you want to do? You want to get a effective focal length as 100. Okay. Now you want a effective focal length as 100. What should be your variable? Your variable should be thickness. So you have to adjust your thickness such that your focal length should be 100.
Right.
Okay. So what I have to do? First I directly defined this value as a, so I already defined my thickness value as 10.
10. Right.
Now I don't want it as a 10. Now just say that the 10 I am going to make it as 9. What will happen? I can see. This is 98.26. I am making it as a 15. 99.29. So if you change the thickness, it can change the focal length.
Okay, fine.
But this is I can adjust and make it as like a, now 99.46. So I can adjust and make it as 100.
Okay.
But that if I am manually doing that one will be a tiresome job.
Yeah, trial and error.
Yeah, it will be like it will take too much time. So I don't want to do like that way.
Right.
So what I will do, I have an option that I can put it as a variable. Select this thickness as a variable. So also define this as a variable. This thickness is as a variable also defined. Now what I have to do? Now I have to make a error function. So that is here, optimize, generate error function, aberration operands. These are like different functions which is available in Oslo.
Okay, fine.
And in that one, we have one option of EFL,
Right.
OCM21. So you give the value as weightage 1, such that you can take that full weightage for that one. And OCM21 is the name of that value. So it is like each time it will take a value and calculate the difference. So it will generate an error and it will try to minimize that error.
Okay.
So I am saying that I want a 100 focal length.
Right.
So what should be the error? The error should be
minus 30, 98.43.
So I will give the value of that particular focal length. Now whatever the value of the focal length minus 100. That will be my error.
Right.
And it will try to minimize that error. When that error will minimize, means that error value should be 0. When the error value will become 0, when that effective focal length will become 100. So now I defined an error such that OCM21 minus 100. So now I defined that error. This will be error now. Now I want to minimize the error. How it will minimize? What will be the function which will variable? So that you already defined the, what should be the variable thing? You already defined that variable will be the thickness. So it will try to change a small variation in the thickness and find out what will be the error function.
Okay.
And like that way they should do continuously. So we had to do an iteration, and that iteration option is the in this menu. You can see that last option. So just click on that one, iterate, and here you can see how it is variation is happening. That time it was a 98 point something. So that minimum error, like yeah, 1.5 was that error. Then it tried to minimize that error. Then error changed to 0.025. Then again it is changed 6.562. When after sometimes the iteration error is very less and it was almost similar, then Oslo stopped that iteration. Now we can see that we defined like it some 10
Right.
that now became 19.082021, and that effective focal length became 100.
Okay.
So this is the first optimization is done by us to do that question. Now we can go and see the question.
Sir, how do we get this image plane?
Image plane want to see. So so you see this is the image plane. So if you want to see that plane, you have to draw the plane. You have to give the command. Otherwise also the image plane will be there. But Oslo will not show you. In order to show or see that one, you have to give Oslo the information that you should draw that plane. So go to that particular plane. So here you can see that I am saying that after third surface, I have to show the plane. So this will be it will be showing your third plane as well as your image plane. So it will show both the plane such that you will get the original image. Now just I will ask you one question. What will happen if I put a, you can see that some object here. If I draw this object plane, what you will see? Just a guess. Anybody can give a guess? I am going to give surface control here in general, and I am going to tell drawn. What will happen? Any idea? I will tell. Now see what is the thickness here. 1 into 10 raised to 20. 1 into 10 raised to 20 means this is thickness means
It's infinite something.
this is thickness means this is the object distance.
Object distance or
Yeah.
It
This is,
will be at very far, na, like sun or
yeah.
something.
So this thickness is actually from object to the first surface. This will be the distance from this one,
oh,
from some object.
okay.
Actually, object we are not at all seeing. So, but the thickness is, they are saying that this thickness means object distance.
Okay.
So this is from object to your first surface. So this thickness is object distance. Now I am going to tell Oslo that I want to see the object also. What will happen? That distance you see, this is something like a very high distance. If you
It is
put,
coming
yeah,
from infinity,
yeah, it is looking something like infinity.
parallel beam.
And what you are going to see, it is like you are going to see a kilometer distance object and a millimeter object distance object together. Now this is like a very small portion, but now you are saying that you want to see along with this one, you want to see that very far away thing also. So you have to look at this one at a very far distance. So you will see this thing as very small, and you will see very large distance. Let us see how we'll see this one. See, you know what you are seeing? You are only seeing your object. This is your object which is coming at a 1 into 10 raised to 20, and your all lens system will be somewhere here. This is a very big object which is giving a field angle of You see here object aperture radius. This is actually your object height. This is an object having very high size and which is giving a field angle of 20°. This is that object, and this is actually at very far.
Yeah.
But your whole system is actually now here. But you told Oslo that I want to see that object also now. So when you are seeing the object, your whole system is very small, such that now you cannot even distinguish that thing here.
Right.
Okay, this is the thing.
Sir, this field angle is a full view angle.
Yeah, now because here actually whatever you are see, you are telling here, na. Now you told Oslo that you want to see the object also.
Yes.
So it is giving that full
Full
size of
view,
the,
not
yeah,
tan theta, na? It's a tan theta.
yeah. This is, you can see that this angle will be 20. This will be 20°. Along with the, if you make an axial ray, if you make an angle, this will be 20°.
Okay.
This angle will be 20°. Okay. So similar way here. This is actually, you can say this is the half of that angle. This will be 20°. Such that this will be 20 plus 20. This will be your whatever the angle of view, 40° you will get out of this total object.
Oh, okay, sir. That was the doubt that it's a half angle or a full angle.
Yes, yeah. This will come as your half angle.
Okay, sir.
Now the question is not completed. Yeah, our question is still pending. Now the question is like that way. Value of primary axial color and primary lateral color are. How you will get these values? So you have to go to your Oslo and see this thing we already defined. So I want to see what is my prime. Can you see that ABR? These are your aberration values. Just go and click there. Then it will give different aberration values there. The chromatic aberration, sidal aberrations, there are fifth order aberrations. Usually this sidal aberrations are like spherical aberrations are like third order aberrations. So look at the SA3, this is spherical aberration. CMA3, this is a comma. AST3, astigmatism. PTZ, it's a Petzval field curvature. DAS3, it's like a distortion. These are like that way. And chromatic aberration, this axial thing, PAC, PLC, longitudinal and axial variations. You can see here. So they are asking the question that what your thing says here, axial color and primary lateral color. So they want PAC as primary axial color and primary lateral color. So you can directly see PAC. What is the PAC? Minus 0.74582. And primary lateral color.
Sir, but they didn't mention if it's like before optimization or after optimization, sir.
Yeah, that yeah. But that question is coming before optimization, na? Because yeah, only the but in the instruction already there is there, na? 1 minute, I'll just check. Let us see. I think this question may require one. But here and optimize the EFL to be 100 mm. It's already given now first.
Okay.
So here actually it will come like that way only. This one. So till 8 the question is valid. So there will be like a minus 0.07482 0.02644004. You see, this will be, these are the value 0.06002. This is like, actually this is not the original optimization of this is not original this is only optimization of focal length. So all the aberrations are there. If you are optimizing your focal length, aberrations are there. Only you optimize that one. Actually, I think that second part is missing from that your original assignment question. Na? So in the solution, actually you can see, because I also had that confusion when I was doing this assignment. So then I see that in the solution part, actually there is some extra point is there. Using both the radii curvature and the lens thickness as variable, optimize such that primary and secondary axial and lateral color aberration will be minimized and EFL is maintained at 100 mm. This instruction is missing in that original assignment question, it seems, or it is there or not. Is this instruction were there?
No, sir.
It is not there.
Yeah. So this is 9th and 10th question. That's why, because even though then they are saying that after optimization, because here also there was one optimized condition is there. People will think that there is a optimization, because when I go through that way, I got yeah, this lateral color shift as like something similar A. Now you just see that you go in the Oslo. Now you go here. Now you see here, na. Here you can see that lateral color shift.
Sir, which option is this? From where you got this?
You can go, there are different tools here, na. Different window you can see here. In the Oslo, you will get a one spreadsheet window and another window, and there is a yeah. I remove that one. Yeah. Actually, there are four window. Out of one window is this one only, and there are option. I will open once more, and you can see that this lateral color will be something like this way. And actually, by looking here, you have to choose your option there. Here you can see that it's your lateral color will be something like here. You can see this is your 0.05 mm, and around 0.02 mm you have blue is there. Got it? And you have to choose that option there. Now we can see that whether that option is there or not. If that option is there, then that is valid. This is A is something like that way. B is some more higher, and you can see that C is some more lower than that one, and D is some more there. So it is looking like a B and D can be your answer, but their option is a C. That means it is much more lower. So by that time I came to know that there is something missing in between. Some optimization is missing in between. So when you are going through the solutions, you can see that in the solution before the ninth question, there is a one more optimization is here. Here we have to optimize such that primary and secondary axial and lateral color aberrations are minimized, and EFL should be maintained constant. So what you have to do? Just tell.
So we have to maintain 3 operands, you say.
Yeah. So here we have to go. Yeah. You have to optimize generate error function, aberration operand. What are the thing? Primary and secondary axial and lateral color. What are the things? This is PAC's primary axial color. That you have to minimize. Minimize means it should be 0. Then primary lateral color. Give weightage, full weightage. CM6 minus 0. Then secondary axial color. 1, 7, 0. Secondary lateral color. Then well, EFL should be maintained as a 100 itself. Minus 100. You check that you already have your thickness is the variable. Oh, okay. Again, I have to do again because what are the variables that defined? The
So
various.
radius curvature also variable.
Yes. The radius of curvature as well as the thickness are variable. Na?
So even the thickness of the lens, or
What three quantities are variable? They are saying na? No, in the question. It's like a variable we can define, but in the question actually they given means we have to give using both radii of curvature and the lens thickness as variables. So we have to use all three values are variable. So
okay, then the distance between the lens and the image, that is not to be changed.
that that is not a variable actually.
Okay.
Yeah, because EFL should be same.
Okay, fine.
Focal length should be same. So we can say that in an ideal case there will not be any difference between your image and your lens, but there can be one variation. Can you tell why? I am
So if like the lens is like too thick or something, so that variation.
yeah, our effective focal length is actually calculating not from the surface of the lens. Actually, it is calculating from the our principal plane, second principal plane to that where your axial ray height is going to 0. That is actually your EFL. So if now you are going to vary your radius of curvature as well as your thickness. So there can be a chance that there will be a slight variation in your principal plane position. So even though your effective focal length is going to be fixed, sometimes what will change? Your image distance can be changed. Not much, but slightly. Okay? Because that image distance is calculating based on your surface. Whatever the Oslo, here whatever you are seeing, this 93.498411. This is actually calculating from your third surface ending to the image. If your principal plane position is changed and still your EFL is 100, sometimes can be some slight variation. We can see that one now, whether it will change or not. Now it's 93.498. Let us see whether it will change or not. Sometimes it,
So one question. So why did we define a new surface 3? Why didn't we just added the thickness to the
yeah.
second?
No. Here there is no problem because I added only because I was thinking that they will ask for a make a
So is it like
achromatic doublet. I thought,
okay, fine.
yeah, such that I can just insert one glass here and it will be like a new lens. That's why I
Okay,
just
fine.
put it that way. So
Okay.
there is no problem with that one. So this is like that way. Just after the lens, there is nothing. That's a zero thickness area of air, and after that there is a distance. So that you can do, no problem.
Okay.
Yeah. So this I just just thought that they are going to tell a achromatic doublet such that I can just insert a glass here. I thought that's why I just made a extra surface there. So you can, there is no need of that surface here. Actually, you can just put here. Solve. So now I am going to optimize. Now EAC should be 0. And EF should undo EAC, BNC, SSC. Okay. I will iterate and see how much it is weight. I said 93.498 is the image distance it is showing. That surface to image it is showing. Let us see how it is, whether it is changing or not. You see, there is less light variation. Some 3 mm variation was there.
Yes.
Okay. So this is your condition. Now, yeah, now that next question is valid, now we can see choose the closest option of looking the lateral color. Now let us see how much it is coming. Yeah, now itself you can see that. Now you see your lateral color shifting. Now it's a 0.01. Okay, the scale you can see now.
So
This is,
so then should we adjust the scale?
yeah, you can recalculate using the new parameter. So you can say that lateral color scale you can put it as 0.05. I'll see. Now it's
Okay.
much less.
Yes.
So actually, yeah, they are supposed to give that question, that instruction in between. I think that is missed. I will inform them. So it will come like that way. Yeah, the answer is come to be.
We didn't know how that we had to like change the secondary color operands also. So,
But that is,
because then how come we can answer this question?
Yes,
Because I
yes.
got the A option and the D option because I only
Yeah.
changed the primary and the effective
Yeah,
focal.
yeah. Because the same thing happened because I didn't look at that solution. Just I was doing and I saw that the answer there given is wrong. So, but yeah,
Okay.
in the case of Oslo, it is like a if you did that one, you don't need to do much. You can directly look and see. Then I came to know that there should be something missing there. Then I see in the solution that there was some
Okay.
instruction is
Secondary
missing.
also
Yeah,
should be.
yeah. First, yeah, I was thinking that they will ask for some achromatic doublet, but yeah, that was not that much thing was there.
So will we get more marks because we didn't
Yeah,
know that?
mostly you will not get more marks, but that two question maybe get cancelled. The remaining thing.
Okay.
Yeah,
Okay.
the 9 and 10 question I think they will not evaluate it.
Fine. Okay.
What are the value of PIC and PLC after optimization? Now we can go and see. Now it will be like a direct visualization. Go here, go and see that your comparison. Your DAC and PLC. Minus point is 0.76203. PLC is 0.011. Yeah, answer is so that answer is there. So that yeah that instruction is missing there. That's why yeah two people cannot do. I was thinking that they will ask for some achromatic doublet, but yeah, they didn't ask. I think that it is some more similar to that your as in practical question, practical whatever you did that your practical thing. It was some more that first part. I think it's exactly same as your practical only. In that
Yes.
fifth, fifth
First one was we were able to do, but
yeah
second,
yeah second yeah
last
that's
two.
actually not your fault. Yeah, because yeah
Yeah.
that instruction is missing from. Okay. Now, what are the doubts? You can say that our assignment portion is finished. And how you feel that Oslo? Nice or tough or easy
So
or
it
okay?
is very powerful, sir, but the
Keep
EDU
learning.
version 10 surfaces.
Yeah, tensor first means actually you are having option like
So in that, I had one question. So in that, they were asking like in the practice exercises, they were asking like a very specific like numerical aperture. They have, I think, numerical aperture. They have F number. They said a particular F number is required in the practice exercises in
F
Oslo.
F F num
How
F
do we
F
how
number
do we define that in Oslo, sir?
F number they already defined na F by
Huh.
it's a D by F I think
Hi,
D
sir. How do we represent and like say we want to design a lens of like say f by 2 lens or something.
yeah.
So how do we design that in Oslo, sir? Like what parameters should we change?
So if you are making a simple lens, your aperture radius will be your and from there actually you will get the diameter of the lens. Your aperture of the lens will be exactly same as your D.
That will be f1 lenses. Like one full aperture will be same means.
Yeah.
Okay.
So but in the case of you are making a like a doublet or triplet kind of lens, and if you are going to see the lens as a single entity, you have to consider your aperture stop of that lens.
Okay. So
Aperture.
so if they're saying the f number, that means we have to vary the size of our aperture stop. You say.
Yeah. If you are giving the focal length and they are giving the f number means you based on that focal length because focal length and diameter is actually defines your aperture stop. Sorry, f number. So if they are
Okay. So
giving
in this diameter, which what will be the diameter here, sir? The
Diameter
diameter of the aperture stop.
of the aperture stop. Yeah, if it's a simple lens, the diameter of aperture stop is same as the diameter of your lens.
Okay, so and the focal length will be the effective focal length, you say.
Yeah, focal length will be effective focal length. But
So that will give the effective
that will
focal
give,
number.
yeah. So if they are giving the f number means and they are giving
F.
focal length means you can understand what will be the diameter or what will be the size of your aperture stop. That will give.
Okay, so and the another question, so like in microscope objectives are there, no, so
Yes, yes.
there the numbers like 45x and numerical aperture will be 0.65.
Yeah.
So like what all information can we like extract? So, like 45, there's something called like a working F number and all. So like
Yeah.
so any
This
insight on that?
this 45x is actually giving the magnification power.
Yes, sir. And how is it like created?
So it is like you are putting a lens. Yeah, it's like a 45x means this is a part of a tube, and this will be like a predefined thing. So it's like that way. If you are putting an pro- proper objective and eyepiece, there will be like a predefined thing such that you can use that objective in that kind of microscope thing. So there will be a tube here, and there will be a top of the tube. There will be an eyepiece, and the bottom portion you will have a objective. So based on this distance and the power of your lens, they are not at all giving what is the power in terms of what you call terms of diopter and other things, because that thing is going to be a part of your fixed tube which is already defined and well known, such that they are giving that if you are using a 45x objective, and let it be there will be some eyepiece also will be there 10x. So if you are not using it as a part of a original microscope, there is no point like saying that this is a 10x, or
Okay, sir.
there will be a point in such a way that this will image that particular, this will be like a secondary image thing. So this objective will make a big image, and this eyepiece will further magnify it to a virtual image very big in such a way that it will be like a very high. So there will be fixed position corresponding to the lens that where that image will be formed, and that where that object should be located. Here there will be your object will be located at a particular position, and there will be a one image will be forming inside your tube, and that primary image is get magnified by your secondary image, and that whole system is arranged in such a way that this primary objective will form a 45x image of the magnification of that object will be 45x if you are not using any lens, and that image will be get magnified further by your eyepiece, such that altogether you will get a 450x magnification. So you are using a 1 mm object, you will see that image will be something 450 mm.
Okay.
That
Okay.
is the thing. And now comes the numerical aperture. What is the numerical
Yes.
aperture is telling? It is actually telling how much light it can go inside. So if your numerical aperture means, so how much light it can take. So just think that now, so I have a lens. So how much light it can take? Now just think that this is a thick lens. So the light which is coming directly from an axial point, it can nicely image and use all the things. But as you are increasing your angle, your field angle, as you are increasing, there will be limitation such that light can go to the system. So there will be a particular limitation how much light my lens can collect. So that this angle, how much angle I can collect this light is actually the measure of the angle is given by the numerical aperture. So actually this is the sign of the angle. Sign of this half field angle, you can say that is a numerical aperture. So if I have a high numerical aperture means it can collect this much light. I have a low numerical aperture means I can collect only this much light. So what will have a objective lens will have a very small lens here. So that is have a high numerical aperture means you can keep, and this will be very high power lens. So you have to keep a very object at this position, and if this can collect a nice all light coming from the whole part of the object means you will get a nice good image in that image portion. If you are collecting less light means your amount of light reaching the image will be less, or that contrast will be less, that information which is passes through that image will be less. So numerical aperture is giving actually that amount of light which can collect inside the system. In the case of the lens, it will be like a sign of the field angle it will give. Similar way in the case of optical fiber, I think that will optical fiber, I don't know whether it will come in that one. Optical fiber will also have a numerical aperture. That is like a amount of light which can pass through the optical fiber. Because if you go beyond some certain limit, the light will not go undergo total internal refraction. It will just refract through this side. It will leak. But so there will be a limit of that angle through which the light can pass through this optical fiber. So sign of that angle is actually given by numerical aperture of our lens. It is like a same actually it is giving the effective amount of aperture means a width such that it can pass through that system. Actually, it is giving an idea
Okay.
of that.
Yes, sir, yes. And how is this numerical aperture like? So, like, I was looking for the formulas, and they were saying that okay, the f number is related to the numerical aperture inversely, like 1/2 into numerical aperture denominator will give you f number.
1 by, let's see,
1/2 into numerical aperture.
1 by 2 into numerical aperture, you are saying.
Down, sir, down, sir. Numerical aperture is down.
1 by 2 into numerical
NA,
aperture.
huh. That is equal to f number, they are saying, sir. And then there's another call saying that the working f number is 1 plus the magnification into the f number, normal f number. So I was getting confused, like what is working f number and normal f number, and how is it related to numerical aperture?
Okay, if it is something, I will just check that one, and if I can,
Okay,
I will update
okay,
that
okay.
in that
Sure, sir.
discussion form. I will update. You
Okay,
want?
sir. Thank you, sir.
Yeah. A doubt? So I think you people may already have started a Gaussian thing.
What, sir?
That the Gaussian optics started.
Ah, yes, sir.
Yeah. Okay, that is the first video. You people have some issue.
Yes, sir.
So now, and now from the geometrical optics, you people are moving to wave optics kind of thing. So that is like also
Yes, sir.
like yeah. It's also something like geometrical optics, but yeah, it's actually the Gaussian is actually, you can say that the
Yes.
wavefront is actually coming because of that. Yeah, the wavefront concept is coming. Wavefront concept is actually the concept of wave optics.
Like how important of a topic will this be, sir? Like,
But
How important? Like, will geometric optics be very important, or this one that we're going to learn right now is
that is actually depends on which field you are going to do.
uh, like which field, as in like what's like
Like if you are going to deal with your imaging, like photography and
okay,
microphotography, astrophotography, all the things you can actually do all the things with your geometrical thing. So imaging
okay,
thing you can nicely do almost all things with the geometrical thing. Still there is actually the limit because the diffraction limit will always play there. Whenever you are going for a
okay,
something small aperture or something, that diffraction will limit you. So
okay,
yeah, but in the case of like a normal photo and other things, it will be like a you can nicely go with the geometrical thing. But
okay,
yeah, this Gaussian thing actually will come mainly if you are going to use with the laser and like that kind of things. Because there are like all the optical system now we are using with all the laser thing. Inherently, the laser output from a or output beam of a laser is actually a Gaussian in nature. If you took a
okay,
transverse section, the laser output will be Gaussian wave. The middle portion will be high intense and the periphery will be low intense. So there itself actually, and the Gaussian has a autofocusing tendency by itself. So even though
okay,
if you didn't put any lens also, the Gaussian beam have a focal spot, an inherent focal spot. So it's like a
okay.
completely different from now you are thinking that okay, one beam of light is coming from a laser source. But if you are
Yes,
thinking
sir.
that like that way, it is not like a parallel beam. That beam itself has an inherent tendency to focus by itself and it will diverge after some time. So it's like a you have to understand how the Gaussian is working. Otherwise, you will think that it's a parallel beam, and if you put some lens to focus that one, but this is not a parallel beam. It already has a particular focusing tendency, and you are
Yes,
thinking that you are going to put a particular. So, if you are going to put some optical element in between, you have to be much careful that where you are going to put, because that the tendency of the beam is completely depends on that inherent tendency as well as the optical element which you are going to use. So you have to be much more careful when you are doing with this kind of. But yeah, these things are actually nice. You people having any practical means not here practical experience with this kind of thing?
no, sir. Only like the binocular thing is the last thing I had.
And you people maybe have known about pinhole camera.
Huh, pinhole camera we have
Yeah.
that in what fifth standard or sixth
Uh,
standard we were on.
how you are making? You are making a cardboard box and
Yes, sir, and pin and
yeah, yeah. I will tell like that way. I because I had an assignment for this pinhole camera during my when I was doing my optical thing course, and actually I can say that that time yeah when I was kid I used to make the pinhole camera like that way only. But you can actually
yes,
do. You can do. You know that original DSLR camera na
yes, sir.
where you can change your lens
Huh.
and just that time I got a thought that instead of a lens whether I can use a pinhole even though
Yes,
without
sir. The F number will be like very, very small and you'll be able to
yeah.
capture it.
So
Nice.
I just put an aluminum foil and a hole and I tried to take an image. There was a nice image is coming. It's a blurred but it's an image.
Huh.
then i
Yes,
s-
yes,
then I searched the internet. You can see that they're making that kind of things. That's actually just completely working based on geometrical optics.
yes, sir.
Yeah, it's like you are putting a very small aperture and the light from one point is actually getting imaged. Only the thing is that you have to give your exposure time high enough to get a proper intensity. So these are like this course is actually I like very much such that these are giving some nice idea around
Yes.
what is happening. I don't know how you people are feeling, but I felt like that.
He's a very, very interesting person.
Yeah. Any doubt?
no doubt from my side.